This is the second example for rational function graphing. So for the second one, we have r of x is equal to x squared minus x minus 6 divided by x squared minus 7x plus 12. So I'm going to first of all fully factor the numerator and the denominator. So in the numerator, it factors to x minus 3 and x plus 2. And then in the denominator, I have a x minus 3 and a x minus 4. Okay, so notice on this one, I have a common factor, which are these here. So see that's right here. This is a common factor. So I'm going to reduce it and just call my new rational function as x plus 2 and x minus 4. All right, so this is actually going to come out to be exactly the same as what this is, except for this particular point. Okay, so my vertical asymptote here is going to be, I'm going to look at my reduced one, and so that's going to be at x is equal to 4. And I have a horizontal asymptote because my numerator's power is equal to my denominators. So then I take the coefficient, so that'll be y is equal to 1. All right, so I'm just looking at x squared and an x squared, and then I just look at the coefficients of 1 and 1, so then it's going to be y is equal to 1. Now there is a hole on this because there is a common factor. So that's going to occur at x is equal to 3, right? So at x is equal to 3, there's going to be a hole. And then to find the y value, I put it back into the reduced equation. Okay, so to find the y value, substitute in reduced equation. Okay, so then I put 3 back in here, and that gives me a negative 5. So y is equal to a negative 5. That's where the y value of the hole is. The domain is going to be wherever the vertical asymptotes are, along with any holes that occur. So it'll be all reals such that x does not equal 4 and also a 3. So x-intercept is where y is equal to 0. So I'll look at my numerator on this one here, and that's going to be at a negative 2. And my y-intercept is where x is equal to 0, so I'll just do this covering up method again. So I just put my finger on the original function and just cover up all of my x's, and I get negative 1/2 as my answer. Okay, and then for my truth table, I have x, y, and I'm only looking at my vertical asymptotes. I don't consider my hole. So it'll be 4 to the left side of it, and then 4 to the right side of it. And I'm going to just put it in my reduced equation right up here. Okay, so if I put in 4 to the left side of it, to the negative side of it, like 3, this will be a positive and a negative. Right? So this will be a negative infinity. And then if I put in a value that is to the right of 4, it'll be a positive positive, so it'll be a positive infinity. Okay, now I'm ready to draw out my graph. So I'm going to put in my vertical asymptote and my horizontal asymptote. So my vertical asymptote is at 4. So I'll draw my vertical asymptote using a dotted line of 4. And then I'll use the horizontal asymptote is y is equal to 1. So that'll be here. And then I'll put in my x-intercept of a negative 2. So that's going to be here. And then my y-intercept of a negative 1/2, which will be right here. And then I just draw in I also need to put in my hole. So at 3, 1, 2, 3, there's a hole at a negative 5. So that'll be right here. Okay, so now when I draw in my graph, I know that to the left of 4, so that's on this side here, it's going to go down to a negative infinity. And then there's a horizontal asymptote at y is equal to 1, so that it has to be drawn through this way, like this, and down through this way. And then from my other side, there's no asymptote, so I know that it can't be up in this area. And I also know it can't be in this area because there's no more intercepts. And so then the other part has to be up in this region right here. So there is my graph.